In today's lesson, we're going to be looking at how we can solve logarithmic equations with just one logarithm. And we're going to move on next time to more complex equations. But just as a reminder, you may remember this graphic from some time ago where we kind of looked at how we can move from an exponential equation to a logarithmic equation. And so we identified our base and our exponent, and of course this is, the product or the result of those things. But we want to go in the opposite direction. So we have this little pattern, or we'll call it a loop, where we started from the base and we went by this output and we got to the exponent. That allowed us to get what we have here, right? The base, or log base b of y, is equal to x, okay? That's how we can go from exponential to logarithmic. But pretty much the same kind of pattern works when we want to take it in the opposite direction. Remember that the output of a logarithm represents an exponent for something, right? Here's that x, and we can see it as an exponent over here. So I can do that same kind of loop, starting here with my base b and my exponent x. And so we'll say base b raised to power x gives us y, which is exactly what we have over here. And this is why we say that logs and exponential functions are inverses of each other, because they undo one another, okay? So again, what we're going to be using today is we're going to look at this base, we're going to raise it to this exponent, and it's going to be equal to this value. So let's take a look at our first example. Here we have log base 9 of t is equal to 2. So our base is 9. We're going to raise that to the second power, and it's going to be equal to t. And so in this example, we get t is equal to 81. All right. In a similar example, we're looking at log of w is equal to 2. I want to remind you that when we have just log, the base is 10. So it's log base 10, or rather 10 raised to the second power is going to be equal to w. Okay, we start at the 10. This is our exponent. It's equal to w. And of course, we know 10 squared is equal to 100. Okay, here's another one. And in this problem, thinking about my log properties, one thing I could do is take this 6 and bring it back over here as an exponent, right? That's what we worked on in our last skill. And so we had log base 7 of z to the 6 is equal to 12. And from there, I can start my loop, right? The base is 7. My exponent is going to be 12. It's going to be equal to z to the 6th. So z to the 6th is equal to 7 to the 12th. Of course, I want to solve for just z. And so we get z, or the 6th root of z to the 6th, is equal to the 6th root of 7 to the 12th. Okay, so we get z over here and 7 squared on the right side. And of course, we get z is equal to 49. Now, we're trying to learn about our log properties, so I suggest that you work through this so that you become comfortable with all of the properties. However, you could have divided both sides by 6 from the beginning, and that would have gotten us there as well. But I want you to remember that you can take that power property that we studied last time and use it in both directions. Okay, here's another one. We're looking at natural log of z, and in this one, our base is e. So we're going to take e and raise it to the 5th power, and then that's going to be equal to z. So we get z is equal to e to the fifth, and we'll use our calculator to find out what e to the fifth is. We get z is equal to 148.41. All right, our next example is log base 16 of w equals 1/2. Just wanted to use this one because it's got a fraction there, but it works the same. There's nothing different. So I forgot to put the original problem, but it starts out as log base 16 of w is equal to 1/2. So that is 16 to the 1/2 equals w. If we're raising 16 to the 1/2, that's the same thing as taking the square root of 16. And so we get w is equal to 4. And there's the original problem. All right, in this example, it looks a little interesting because we've got the fractions, we got a negative on our x here, and then the 64 is starting to get a little large, but that's okay. We're gonna just take it one step at a time and do what we know. We're gonna use that loop to set up our equation. So we can say that 64 raised to the 1/3 power is gonna be equal to negative x. Okay, 64 to the 1/3 equals negative x. If we have something raised to the 1/3 power, that's the same thing as taking the cube root of that number. And the cube root of 64 is 4. So we would get negative x is equal to 4, or we can say x is equal to negative 4. All right, this one is similar to something that we did earlier. Again, I used my log properties instead of dividing both sides by 4. So if I use those log properties, this becomes log base 8 of y to the 4th is equal to 8. All right, now I have a base of 8. My exponent is also 8, and that's going to be equal to y to the 4th. All right. I can take the 4th root of both sides. I don't really need to know exactly what 8 to the 8th is. I'm going to take the 4th root of both sides. And so we get y is equal to 8 squared. And that's something a little more manageable. We know that y is equal to 64. Okay, so in this one, looks a little interesting, but still just take it one step at a time, right? This is just an algebraic expression. Otherwise, everything works the same. So let's take the first step, and then if we need to use some other skills, to solve it, then we can do that. But my base is 9. Okay, our exponent is going to be 1, and this is going to be equal to 2y minus 3. And so we add 3 to both sides, and then we divide both sides by 2, and we get 6 is equal to y. All right, so that's it. Hopefully those examples will help you get through the skill that you're working on today. Again, this is GJH. Solve logarithmic equations with one logarithm. We'll jump into more complex equations next time.